All right, the last section of this lesson on translations deals with vectors. We haven't really heard that term before. You may have in some of your other classes, but we've got some definitions to sort through first before we get into how to use vectors to translate objects. So the definition of a vector is this. Vector is a quantity that has both direction and magnitude. When we say magnitude, we mean size. So a vector is a quantity that has both direction and size or magnitude. Okay, so what you see down below here can be read as vector FG. And if you look up here, the way that we write that, it almost looks like ray FG. It looks like this is an arrow, but if you look closely, it might be kind of hard to see in your notes. It's almost like a half arrow when you get to that point, and that is read as vector FG. So a couple different parts of this that we need to recognize, and here's the filled in version of that. This initial point is F. In other words, where are we starting? That's the initial point, and where are we ending after we move in this certain direction? Remember, a vector is a quantity that has direction. So we're starting with F. Since we're moving towards G and ending at G, G is considered to be the terminal point, so you can mark that as well. And since there is movement, we're moving horizontally, we're moving vertically, and so the direction we're moving left or right is called the horizontal component. The direction we're moving up or down, in this case up, is called the vertical component. The way that we write this, and this is something that's probably brand new to you, which is what we call being written in component form, takes that horizontal and vertical aspect to it, and it rewrites it. It almost looks like a coordinate. We'd say the component of the form of vector FG is 5, 3. Except for these aren't parentheses like you'd see with a coordinate. They're kind of these straight, I don't know how to describe them, but straight lines that contain 5, 3. And this means I moved positive 5, so 5 units to the right, and positive 3, so 3 units up. That was the direction in which my vector was going. Okay, with that in mind, go to the next sheet in your notes, and we'll take a look at this. The first section there says this vector, and you can see it ends up at H. It's got the little arrow down there. It's starting at G. So the vector is GH. That means the initial point is G. The terminal point is H. To get there, I know we're moving, it looks like we're moving diagonally down, but really that diagonal motion is made up of left and right movement and up and down movement. So really we started by going 5 units to the right. In other words, 5 units in a positive direction. Then we went 2 units down, which would be a negative direction. Okay, so that's why we'd say the component form of this vector, GH, is written as 5, negative 2, because we moved from start to finish, positive 5 to the right, negative 2 down. Same thing that you can see down here, different vector VW. We're going from V down and to the left, or I should say to the left and then down to get down to W. So the initial point is V, the terminal point is W. How far did we move left and right? Well, 7 in a negative direction, left direction, and 3 down, so that we got at that terminal point W. So again, we'd write that component form in this way, -7, -3. So let's put that into practice. We've got a triangle ABC, and that's shown here. That's based on these coordinates that are provided to us. And we're coming up with a new prime image of that triangle. So this is what it's going to end up looking like. Prime A, prime B, prime C, using a vector. Well, the vector is showing us that we want to go -4 along the x-axis. In other words, 4 shifted to the left in a negative direction, and then 1 up, which is going along the y-axis. Okay, so instead of the rules that we used before, now we're using a vector to create that new prime image. Okay, so here's how we do that. It says first graph ABC. I've got that done over here. You can pause this and do that on your own if you need to. And then we're going to use that vector, negative 4, 1, to move every single point. Now we're gonna just do the vertices, the three major points, and connect them. But we could do this with any point on this initial triangle. We're gonna go negative 4 units from those initial points to the left because it's negative, and then 1 unit up. And so I'm showing that here with C to go negative 4 units this way, 1 unit up, and that's what's going to give us our prime coordinates. So here's C prime. You do the same thing with A, you do the same thing with B to B prime, and now you've got your 3 major points. When you connect those 3 points, you've got your new triangle, and it says, notice that the vectors drawn from the pre-image to the image are parallel. I didn't actually draw those lines, but what they're talking about is that if you drew a vector, an actual line going from A to A prime, and another one from B to B prime, and another one from C to C prime, you would have 3 diagonal lines and they would all be parallel. You could consider them to be written like this if you drew those actual lines or line segments. You would see that all 3 of those end up being parallel because every single point is shifted in the same direction there.